Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the last week of this ongoing online course on understanding and reducing greenhouse gas emissions, and we are primarily focusing on scope 1 and 2 emission reduction through building design and construction. In this particular week, we are going to see some of the calculations. We have seen a lot of theory, we have seen a lot of examples, we saw how this entire concept of greenhouse gas emissions and accounting came into existence and why. And then we saw that when we are focusing on building design and construction, what all should be done to reduce the GHG emissions. In theory, we have seen all of that, but we have to know exactly how much would it save. How do we calculate that how much would a particular strategy, a solution give me as GHG savings. So, this is what we are going to see very briefly through certain examples, because the calculations could be very vast depending upon what you are wanting to do, but we will only touch upon some specific aspects, and here today we are covering the aspect of calculation of emission reduction through HVAC system design. So, we are looking only at HVAC system, which is a culprit in majority of the cases. So, before I start talking about how the calculations would go, some basic terminology that we have to understand, I will quickly go through that. The first thing which we have to know is a degree day. So, what is a degree day? It could be a cooling degree day or a heating degree day. So, it is basically the measure of heating and cooling that is required in a place. So, how warm or how cold a particular place is determined by degree days. And how do we do that? So, we have a benchmark, we have a standard temperature for different places, it varies. So, if you look at United States of America, there the standard temperature which is used to calculate degree day is 65 degree Fahrenheit. If we look at it in India, we have set it at 18 degree centigrade, almost similar, but we in India would consider 18 degree centigrade as the standard temperature. Now, if we have to calculate the cooling degree days, so what we are doing? We are taking the average of the peaks, the minimum and maximum of each day, and subtracting the standard temperature from it, and the difference that we get is the number of cooling degree day. So, what it means is that for every degree rise than the standard temperature for one day, it is equivalent to 1 degree day. So, if for example, if the peak temperature is say 28 degree centigrade on a particular day, the average temperature. So, the degree days is going to be 10. If we are taking it on an hourly basis and then converting it, so then we would know that for 1 hour the temperature remains 28. So, 28 minus 18, 10 degree centigrade for 1 hour. That is only degree in an hour. If it remains that for 24 hours, or we can divide it by 24 hours to get the heating degree day or cooling degree day. So, similar thing we will do for all the places. Now, why is it relevant is we would know how much heating and cooling is to be done, standard remains the same. If we increase or decrease the standard temperature, it is the same temperature. So, here we have taken 65 degree Fahrenheit, this particular image is for United States of America. So, if we increase it and we will get lesser number of cooling degree days. So, what will happen automatically is we will get more number of heating degree days. It would not matter much, but what will matter, we will come to that, is the set point. So, where you are setting your air conditioning system, what is the cutoff, what is the set point, that is the separate part. So, this is degree day, heating degree day or cooling degree day. Now, what will affect the performance, the energy consumption of an HVAC system is its coefficient of performance. So, what is coefficient of performance? How much is the output capacity, how much heat is it able to extract or provide upon divided by the power input, how much electricity has it consumed to do that much job. That is the coefficient of performance. Both are energies, but we are looking at the work that is done in form of energy, how much heat has been removed per hour versus how much power input has been given in watts. So, this is what we are taking as COP. Now, what we want is, we want COPs to be higher. Higher COP implies more work done with less electricity supplied. So, whenever we are talking about the energy consumption due to HVAC, COP becomes extremely important. We are going to look at the COP when we are doing all the calculations. This is the second. We can also calculate COP if we have been given the temperature. So, in case we are looking at COP cooling, which is predominantly the case for us, India being a tropical country. So, what we have is T cold. So, this is the temperature that is going to be maintained inside the cooled space. We have the outdoor temperature T hot and again the same indoor temperature. So, the temperature to be maintained upon the delta T. How much is that delta T? This will give us the COP of cooling also. Again, quickly understanding the terminology and the process that is happening. Here if we look at cooling, the cooling coefficient of performance, we are looking at the heat that has to be removed from the cold area which is to be cooled and how much heat is given, taken from here and given to the environment, plus there is some work. So, work done, this is the amount of heat which is extracted from the cold area and that is your coefficient of performance for cooling, which is exactly what the COP was. Now, the other thing that I was coming to was the set point temperature. You must have seen a lot of advertisement everywhere that have a set point, cooling set point as higher. What does it mean? If I have set my air conditioner at 16 degree centigrade, so every time the temperature within my space which is being cooled increases from 16, if it becomes 16, the air conditioning will start to work and it will bring down the temperature to 16 by removing that excess heat which has been gained by the space for a lot of reasons. So, if I change my set point to say 20, the air conditioner will not start unless the temperature has increased beyond 20 degree centigrade, or if I increase it to further 24 degree centigrade, the AC will not start until the 24 degree temperature has been crossed. So, we can change the set points to achieve significant amount of energy saving, energy efficiency while using the HVAC. So, what we have to see is what is the set point, and before even doing that we have to decide what is the COP of my HVAC system that I am going to use. Now, if I have to explain to you very clearly, so what we are actually doing is, we are say for example 3 kilowatt of heat energy from outside air. We are overall we are removing 5 kilowatt of heat energy by supplying approximately 2 kilowatt of electrical energy. So, the coefficient of performance is going to be 5 kilowatt upon 2 kilowatt, which is the COP 2.5. This is the total heat that is there in the space, absolute removal, the total work done in terms of energy extraction is say 5 kilowatt and the energy supplied for this is 2 kilowatt. So, we will get the coefficient of performance. Now, if any of these three is given, we can calculate how much is the total work done, or what is the COP, or if COP is given and the total work to be done is given, we will know how much of the energy is going to be consumed. Now, if I have say same work to be done, if I have to remove 5 kilowatt of heat, 5 kilowatt of heat to be removed with an air conditioner of COP 2.5, I know that I will have an electrical energy consumption of 2 kilowatts. Compare it with another system which has a COP of 5. What will I get? I will get reduction in my electrical energy consumption, which will be 1 kilowatt. So, overall, now this is not a correct terminology to be used. We have to know for how many hours is the system running at this performance. So, we always will get energy consumption in kilowatt hours. Assuming this is the case for 1 hour, we will get 2 kilowatt hour and 1 kilowatt hour. So, COP will have a direct influence. You double the COP, the electrical energy consumption will reduce by half. Now, this saving that we have achieved, which is of 1 kilowatt hour, we can directly convert it depending upon which fuel are you using and what are the coefficients, what is the emission coefficient for the given state, the given country. So, if we look at it in India, we know that the carbon emissions from 1 kilowatt hour energy generated is equivalent to 0.85 kilogram of CO2. So, we can simply multiply that in 1 hour. If you change the COP of HVAC system from 2.5 to 5, we will have an emission saving, carbon emission saving of 0.85 kilograms. So, this is how we can calculate how much is the energy saved if we change the COP and how much will be the carbon emission reduction. This is for COP. In case we are asked to check the set point temperatures, we can also change the we cannot change the cooling degree days and heating degree days, they remain the same. We can only change the set point of the system. So, depending upon the set point of the system, with the help of this formula, we can arrive at the COP and then we can calculate the energy savings. So, if we reduce this temperature, if this temperature is lower here, so we will have this value as higher, which implies that the COP will get affected directly, but the T cold here also will change. So, if we reduce the set point temperature, lesser cooling is required, or if the set point is higher in case of cooling and lower in case of heating, we will reduce the energy consumption and directly calculate the carbon emissions. I will stop here today with this, and we will look at some examples of calculations for other aspects of building design and construction also, but largely related to scope 2 emissions. We are not looking at scope 3 emissions and the calculations where embodied energy and life cycle emissions are concerned. We are largely looking at the scope 1, which is direct emissions, and scope 2, which is the reduction or purchased electricity, emissions through purchased energy. So, we will look at some more examples and aspects of building design tomorrow. Thank you very much for joining me.